Okay, good afternoon, ladies and gentlemen, and welcome to this webinar on a sustainable approach to overcoming coastal erosion in Vietnam. The challenges associated with coastal erosion are increasing, and I'm sure you all agree this is especially true in Vietnam. We all hear buzzwords such as climate change and sea level rise, and the impacts are often seen in the form of eroding coastlines and damage to property. The response often taken is in the form of emergency works, but not necessarily with the desired outcomes. So this webinar aims to provide a better understanding of why coastal erosion occurs and what measures can be taken to overcome the challenges associated with coastal erosion. I hope you find this session informative and that the messages shared by our guest speakers give you a greater appreciation for the challenges faced and how they may be overcome. My name is Justin Cross. I'm a director with Royal Esconing DHV in Ho Chi Minh City here in Vietnam. And it's my pleasure to open today's webinar and welcome you all for these discussions. Before I introduce our guest speakers, I would like to thank all of you for joining us. I believe we have over 230 people signed up for today's webinar, and I see the numbers still increasing, people still joining us, and I'm sure it's going to be a good turnout. I'd also like to take this opportunity to make a special mention of some of our guests of honor. So starting with the representatives from Department of Agriculture and Rural Development of Ho Chi Minh City, of Da Nang, of Quang Nam, of Ben Tre, and of Khao Mau. I'd also like to welcome the representatives from the Department of Construction of Ho Chi Minh City, of Phu Yen, of Can Hoa, of Binh Thuan, and of Soc Tran. I'd also like to welcome the Directorate of Water Resources within the Ministry of Agriculture and Rural Development. Welcome the Department of Climate Change within the Ministry of Natural Resources and Environment. And welcome the Urban Development Agency from within the Ministry of Construction. I'm going to hand over to our first guest speakers now, and they come to us from the World Bank. Dung Nguyen is a Senior Disaster Risk Management Specialist. In addition to his extensive experience in disaster risk management, he has also worked in various fields such as agriculture development, irrigation engineering, and water resource management, to name just a few. Here he has promoted and leveraged climate and disaster resilience in policy development and investment. He is joined by Matthijs van Ledden. Matthijs has a PhD in river and coastal engineering. He comes from a consultancy background and has been involved in various coastal and riverine projects. Notably, he spent time with the US Army Corps to support the reconstruction of the levee system around New Orleans following the damage caused by Hurricane Katrina. Since 2017, he's been a subject matter specialist at World Bank. Over to Dung and Matthijs.
Yeah, thank you very much, Justin. Good afternoon, everyone. I'm very proud actually to be a speaker, one of the speakers at the workshop, as Justin already introduced myself. So in our presentation from the World Bank, we have two persons, including me and my colleague, Matthijs van Ledden. We'll go through the short presentation. Our presentation actually focus on to give you some of the very brief analytical results of one of the flagship reports that made in the World Bank in Vietnam. So that's a small background for you to have information that back to 2017, the government of Vietnam actually requested the World Bank for the support on the coastal resilience. By that time, of course, there were a serious issue of resilience along the coast, as well as also including also the coastal erosion were hitting the coast of Vietnam. So the government requested World Bank for the support. So we formulated a team, including all the senior experts around the world, to conduct that analysis. So the analysis actually took more than a year to complete with extensive consultation with the relevant department in Vietnam, a ministry in Vietnam, including also the planning, financing, construction, agriculture, water resources, environment, and many others. We also had the study also actually got the also consultation with a couple of provincial coastal provinces in Vietnam as well. At the result, I'm very proud actually to inform you that the result of the analysis actually also were also included into the December meeting section of the National Assembly in 2019, and also one of the key priorities in the government resolution for the coastal resilience that adopted by the government of Vietnam in also early 2020s. Let me share my screen. Okay. Okay. Hope you all actually see the screen. Okay. I don't actually need to give you the damage finger in the countries which you already seen in. You're already familiar with this. But the bottom line of this, Vietnam is one of the most vulnerable countries to the disaster in the world. So every year the damage, the direct damage actually costs about 1 to 1.5% of the national GDPs in Vietnam. With this, so our study actually focused on a couple of the key or major hazards in the coastal area, including also fluvial flooding, coastal flooding, sea level rise, erosion, and some other and drought as well as soil intrusion along the coast. So of course we use the combination of couple hazard scenario, as you already seen on this in the slide. Together with this, we actually overlay the different scenario of hazards with some of the very key economic sectors and infrastructure sector, including agriculture, aquaculture, industrials, tourism, energy, transport, urban development, school and healthcare facilities. There was actually the key services and key economic activities in Vietnam, particularly concentrated high in the coastal area. All right, so we actually produced a short animation video that capturing and highlighting the key results of the analysis, which actually also try to show the participant the understanding of what level of the risks that the coastal provinces have been facing in the region here, and what would be also the risks in the futures. The organizer, may I actually ask you to share the video to the participant, please? Thank you.
With a coastline of over 3,200 kilometers, Vietnam is endowed with coastal areas that have the potential to be powerful engines of development and prosperity. That is, if natural shocks don't put it all at risk. Typhoons, tropical depressions, storm surges, floods, coastal erosion, and saltwater intrusion regularly threaten livelihoods and revert years of successful development. Such climatic shocks impact virtually all key economic sectors: agriculture, fisheries, tourism, and industry. Lifeline infrastructure systems like energy, transport, and water face heavy disruptions, while essential public services such as schools and hospitals are affected. In Vietnam, more than $2 billion in assets are lost every year due to natural hazards. And that doesn't even count the impact of disasters on people's well-being and livelihoods. The country has been hard at work, making impressive progress in managing disaster risks. Over the years, the government has put in place strong legislation, effective weather forecasting, successful community-based programs, and an extensive dike system. But urbanization in coastal areas is rapidly growing. This also means that more and more people are at risk, and new developments are focused in high-risk areas as safe locations are already occupied. Climate change will only increase these challenges. In the face of increasing disaster risks, the World Bank's Resilient Shores report highlights 5 key recommendations to help Vietnam strengthen the resilience of socio-economic development in coastal zones. Better hazard data and asset management systems need to be established to enable people to make robust decisions in all sectors. Risk-informed spatial and urban planning needs to be ensured to keep people safe and make resilient investment decisions. The resilience in infrastructure systems needs to be strengthened through reinforced safety standards and better design and maintenance. Upgrading dikes is a necessity. Nature-based solutions have a lot to offer and must not be overlooked. Restoring and protecting natural shields such as sand dunes and mangroves not only increases coastal resilience, but yields valuable economic opportunities for communities. Early warning systems need to be improved, while emergency planning, civil protection, and a comprehensive national financial protection strategy can greatly improve Vietnam's capacity to respond and recover from shocks. Vietnam's coastal areas have potential to be home to prosperous and resilient communities, towns, and cities. However, opportunities in the coast come with risks that need to be managed. But by striking a balance between risk and opportunity, it is possible to safeguard Vietnam's coastal development for generations to come.
Yeah. Thank you so much. Let me go back to the presentation. Okay, over to you, Mark Tai.
Thank you, Zoom. And next slide, please.
Yeah, I'm trying. Why it doesn't move? Okay, sorry. Here it is. Okay.
Yes, please also show the graph. Thanks. So thanks everyone, and also welcome from my side. In the coming slides, I'd like to show you some of the underlying analytics of this video. And this to start with this slide, here you see the nightlife growth in Vietnam between 2012 and 2017. And what has been done, it has been overlaid with flood maps to see where there is the highest growth of nightlife. And what you clearly see from this analytics is that there is a strong growth ongoing in the coastal zone, as you see on the right-hand side in the graph of Vietnam. But also, what is maybe more important is that high growth happens in areas which are more vulnerable to flooding. Next slide, please.
I think the computer actually reacts slowly. Oops. I'm sorry. Oops. Perhaps we need help from organizer.
Sure.
If you also can please open the presentation and help us to manage it. I think there's some technology problem in my side. Thank you. Yes.
Can you start sharing the full screen, Lynn? This slide, yes, please. Thank you. Yeah, this is another example of one of the results. So the graphic here shows you the people who are at risk in the various coastal provinces in Vietnam. Very clearly, this graphic shows that mainly in the north, in the Red River Delta and the various provinces over there, but also in the south, in the Mekong Delta, the most people are exposed. So those areas are called the so-called flood risk hotspots. Next slide, please. So as Dung already said, we have made in this report an analysis of all kinds of sectors in Vietnam, and I think what is highlighted from this report, and I think that's also the main takeaway for let's say maybe this audience, is that not only tourism assets are at risk, but also a wide variety of other sectors are at risk, and those are of course also very important for the well-being and also for the growth and sustainable growth of the tourism sector. So it includes people, towns, but also industry and schools, healthcare systems. So all these assets and all these people who work there or have a job there are at risk. Next slide, please. This slide tells you the story about one specific asset system, which is very important for certain areas of Vietnam. It's about the dike system, especially in the north and also in the south. So in the Red River Delta and in the Mekong Delta, there is an extensive dike system that protects the area from flooding, and also the communities in those areas. And the report has made an analysis how the current dike system compares to the safety standards that have been set by MART. And it shows, let's say, that many of the dikes in Vietnam do not meet the prescribed safety standards, and significant investment is necessary to bring them up to the standard. And even then, the safety standards in itself, that's also something with the significant growth in the coastal areas. There is also a need maybe to upgrade these safety standards even further and to protect all these economic value and people who live in the coastal zone. Next slide, please. As already introduced earlier in this presentation, coastal erosion is a very significant problem in the entire coastal zone of Vietnam. And one of the most prominent places is shown here, it's Hoi An, which shows the significant erosion in this location. But this location is not unique. Many locations show severe signs of erosion, and it has been estimated that about 22% of the coastline of Vietnam is vulnerable to erosion. Next slide, please. So if you zoom in specifically on tourism, then coastal erosion is a serious threat. As part of this analysis, there has been made a consistent data set for 5,658 hotels all across Vietnam, and that data set has been used to overlay it with coastal erosion maps, but also with flood maps. And it clearly shows that 60% of the hotels are located within 5 kilometers of the coast in Vietnam, and almost half of them are located near a coastline with strong or moderate erosion. So it shows you again that coastal erosion is a nationwide issue, but it's a particular threat to the tourism industry in Vietnam. Next slide, please. This is just another example on the impact of coastal erosion on tourism. So on the left side, you see the intersect between tourism and hotels for the various provinces and coastal erosion. So you see, especially also in the central part of the coast of Vietnam, there are many hotels who are exposed to erosion. Yeah, all these numbers actually clearly point towards the same direction. Coastal risk from flooding and erosion is high, and more rigorous and joint efforts is required to tackle this issue. Next slide, please. In the analysis of the Resilient Shores report, we also zoomed into various coastal hotspots to see what kind of strategy could be followed to make the coastline more sustainable. And one of those locations is Van Thiet. And this location has a rapidly developing local economy, and it's also a touristic hotspot which received 4 million visitors in 2017. But also this area has seen, let's say, severe erosion at several places. In some places, the coastline retreated with over 100 meters. Next slide, please. So if you walk along the coastline in this area, then you see various tries of all kinds of solutions to combat erosion, from concrete blocks, concrete revetments, geobags, all kinds of let's say solutions have been tried, but none of them have been very successful. And what you can also see is that often these solutions have been taken at a local level to protect one or two specific resorts or a specific section of the coast. I think the analysis that has been carried out for this specific area is that it's both the coastline is of course not a static kind of situation. It varies because of storms, so it can sometimes retreat a bit, but sometimes it can also grow back to the original situation. So building, let's say, assets very close to the coast sounds maybe attractive, but it's not a very good idea. And also, let's say, these hard structures often, let's say, interrupt the natural sand transport along the coast, which also often gives downstream effects to other locations. Next slide, please. So the study that was done for this particular area has proposed, let's say, a more system-wide solution, rather than all these kind of local measures. This study has proposed large-scale beach nourishment for the area, and also a shelter belt, and it requires also the removal of existing regimental structures, and in some places also managing coastal retreat to allow more natural beach dynamics, and strict enforcement to land use planning regulations. Of course, such a large scale and more comprehensive solution will only come with the input and willingness of many stakeholders. And the Van Thiet situation highlights the need, first of all, let's say, strategic guidance from the provincial government, but also input and involvement from the private sector to, for instance, partly finance these erosion protection measures together. But and it will require a long-term commitment and collaboration between public and private partners to identify common interests, and then finance and implement and maintain these measures, such as beach nourishment and the shelter belts. So with that, Zoom, it's back to you.
Yeah, thank you, Matai. So you all see that through the presentation, that is summarized. You see the nightline image that presented in earlier slide. You see we made a comparison from 19 to 2017. So we found that more than 3% of the access concentration and the population developed in the coastal thus after 20 years. That actually exposed all of the population and access and business activities to be more vulnerable to the coastal disasters. Given with this, the fast development of the access and population and economic activities, you can see actually thus the dye system itself in Vietnam. Thus, 65% of the dye system actually under under the standard. So which means you see is how rich of the coastal, how rich of the people and the coastal and the activity, which you need activity along the coast in Vietnam right now. So given with that, if the government delay taking action in 10 years, and then the coastal provinces, would mean 28 coastal provinces, will lose the additional $4.2 billion in the next 10 years if the government doesn't take any action right now. So with that, the World Bank actually, in working with the government to formulate some sort of, we call the long-term coastal resilience program, which are the multiple phases of the support. You can see along with the 5 recommendations made by reports, the support actually focus on the 4 themes, which including building understanding of the risks from the government, not only from individual government officer, but also entire planning system of the country, especially spatial planning. At the same time, the better understanding of risks actually can have the infrastructure sectors or line ministries to be able to maintain and contracts, or to build the more resilient the access to be more resilient to the coastal in the coastal area. Together with that, so this the financing is one of the very important that enable community, not only the government, provinces, but also community to be able to mobilize the resources. Thus, for the emergency response and recoveries aftermath of the disaster, as long as also to invest the long-term disaster protection system in their communities. Which include also, like insurance programs or social safety net, the social safety net, that sort of thing actually need to be improved in the countries. Last but not least, of course, emergency response system of the country need to be also improved, particularly at the lower level. For instance, like the last year storm and flood in the coastal area, you probably also have seen a lot in the media that a lot of people actually were living scatteredly in some of the government officer building without some of the basic services provided during their evacuation. The system of, let's say, the system of evacuation infrastructure need to be also put in place along with the basic services provision, and also the early warning system that also need to be improved along the coastal. So next slide, please. Here you see that the last slide from us. You see actually the long-term multiple phases support for the coastal resilience, which included 5 phases and covering for 20 years or 25 years. So each of the phase actually is trying also to build the lesson learned and to build a model for the specific coastal threats or specific coastal in a certain area of the countries, and then can duplicate and scale up further down from the north to the south. So the government of Vietnam right now is working with the World Bank for the first phase investment, which we are expecting to have a start to be implemented in 2023. So I will stop here and over to you, Justin. If any question, both Mark Tai and I are happy to answer. Thank you.
Excellent. Thanks, Zoom. Thanks, Matthijs. Very, very interesting, very good presentation. We will have time for questions at the end. So please have a look at the bottom of your screen. You'll see there's a Q&A section. Please put your questions in there. And at the end, we'll ask the panelists to address those comments. Our next speaker joins us from Royal Skoning GHV, and that is Joost Lansen. Joost is a port and coastal engineer with expertise in hydrodynamics, coastal development and project management. In addition to his role as a specialist consultant, Joost has also lectured part-time at the Delft University of Technology in the Netherlands. Over to you, Joost.
Yes, can you hear me? Thumbs up? Yes, okay, very good. Let me also share my screen. Okay, I hope everybody can see my screen. Yeah, thank you for the nice introduction and also yeah, very nice presentation before me. So what I want to do is to go in my presentation a little bit deeper in more detail in understanding coastal erosion and what can we do about it. So what I will cover in my presentation. So my objective of this presentation is that I will share some of the understanding of the key issues related to erosion. So why does it happen? What can we do about it? And also to share experience from me and our company. How can we define and implement coastal protection solutions? So I will touch upon various topics. The first one is the problem. So what are the problems resulting from coastal erosion? Secondly, what are the causes? So what causes coastal erosion? Thirdly, prevention and solutions. So what can we do about it? And lastly, how can we implement these preventive and protection solutions? A little bit of an introduction about myself. Justin already gave it. So my name is Joost Lansen. So I work over 15 years. I have experience in coastal engineering globally, but I'm working in Vietnam for about 8 years. So I've been working on quite some projects along the coastline, and I've been seeing a lot of changes over time. And I work for Royal Haskoning DHV. So my company, we work in various projects related to coastal engineering. We're originally from the Netherlands, so we have a strong water protection background, and we are active in Vietnam for 40 years, working in coastal resilience. So it's a bit of an introduction about who's talking to you at the moment. So what are the problems related to coastal erosions? So firstly, I think this is a very nice quote, which we found on TripAdvisor. This was a tourist. He came on to holiday to Vietnam, and it reads, after unpacking, we went over and saw the entire beach had been washed away. Had Booking.com informed us? No beach, just a sheer drop to where the waves were crashing into. What a disappointment. Later it says, on our last night, we were having a cocktail on the beach bar, which is hanging on a cliff edge, and a digger came down to the beach as the tide had gone out and was moving sand to try and rectify what obviously had been caused by a monsoon. Now, this shows, and also what's shown in the pictures on the right, is that due to local erosion at various developments, and for the tourist sector, the quality of the beaches is going down, and obviously that's viewed negatively. It's not only the tourist sector, of course. We see also in the news that coastal erosion affects a lot of other types of industries. And so it's also related to fishing ports, but also just people living in residential areas. So not only is it affecting the private tourist sector, but it's actually affecting a lot of the lives of coastal people. And I think Matthijs also showed some nice examples. So what is really the problem then with coastal erosion? So what really the problem is, so coastal erosion leads to a loss of the beach, which in the end results in an unattractive coastline for tourists. And so the beach is gone, which is reducing the experience of the tourists there. It also damages the property. So we see a lot of property being damaged along the coastline. And so when it's being built, often we see a nice beach, but over time, due to erosion or during storms, a lot of property is being damaged. And lastly, there's also a loss of the natural and the cultural value of the coastline. So a lot of people appreciate, obviously, the beautiful Vietnam beaches. It's being used for fisheries, but also by the local population to go out, but it's being lost. Lastly, so the invested value of a lot of these properties is going down. So because of the appreciation of the visitors of a eroded beach, actually the property value will go down because the appreciation is much lower. And we see a lot of these examples along the coastline. So what causes coastal erosion? So I would like to demonstrate in the coming slides a little bit of the engineering insight in why coastal erosion occurs, because we think that's very important to have that understanding to also later on develop protection solutions and management solutions, how you would mitigate erosion. So I will touch upon three main causes. So the first one is natural dynamics. As Matthijs also pointed out, so there's a natural dynamics of erosion and accretion. So that's part of what nature does. And secondly, it's human activities. Human activities have an impact on the coastline. And lastly, climate change. So first of all, if we look at the beach, you see here a very nice beach with water and waves and a surf zone. Actually, this beach is subject to the forces of nature. So that's tides, currents, wind, and waves. So if we look at the coastline, this is a schematic picture. We see that there's a beach, there's water, there's waves. But what you often don't see clearly when you're standing on the beach is that there's a longshore drift. So there's always some kind of flow flowing along the coastline, which transports water, but it also transports sand. And so because what we see, so in the foreshore, there's sand movement, which is being transported by this flow, and it flows as some kind of sand river along the coastline. Not only this is moving sand, but we also see that sand moves from the beach onto the seabed. So throughout the year, sand is moved from the beach onto the seabed. As a result of this, we see actually that there's a natural variation in the accretion and erosion. So during storms or seasonal variations, waves can be higher, and as a result of that, there will be erosion. So sand is actually put in the foreshore, and in the calm season, actually the sand is going back to the beach. So when you visit some beaches at different periods of the year, you would see actually that there's erosion and accretion. So one of the key messages about this is that the coastline is by nature dynamic. So any beach needs also some space to breathe. So when planning and looking at coastal developments, you always need to make sure, let's say, that the coastline can follow its own dynamics and it has this space to breathe. So building close to the coastline is often not a very good idea. Secondly, when we look at human activities, so what we often see is that for property developments, often there are structures being built on the coastline, which actually block this longshore transport I was talking about. And so this flow of sand along the coastline is being blocked, for instance, by a groin. There's an example in this upper right corner. And as a result of it, one side of this groin, actually, because of the blocking, it will get more sand, whereas the other side, there will be less sand, leading to erosion. And what we often see, so the person on the left, he is very happy, so he has a very nice beach, but the person on the right-hand side, obviously, he's less happy because his beach has been eroded by the structure which was built probably by the person to the left. And often this is an ongoing process. And so the next neighbor also will make something, and then the one next to it will be unhappy. So I think the conclusion is, or the takeaway from this, is that when we look at these kind of developments, we also have to look at, let's say, the surroundings, the neighbor. And it's only a solution to, let's say, make a resilient and sustainable beach is to work together, because this process will go on, and it will not solve the problem altogether. So not only we see that with groins, but often we sometimes also see revetments being built. Obviously, this stops the erosion, but also here, the neighbor will be suffering, and it's also questionable whether maybe the erosion is stopped, but this leads to a high-value beach. Now, when we look along the coastline of Vietnam, I think there were some pictures already. So this is a picture of a beach in Mui Ne. This was in 2008. We see a very nice natural coastline. But when we look at the situation today, we see these various structures have been built to protect some beaches along the coastline for various resorts, but at some places the beach has disappeared completely. And so in this particular situation, some people have been protecting their coastline, but by not approaching it in a consistent way with all the neighbors in the areas, about half of the beach has disappeared. Now, when we look at the third cause of coastal erosion, that's climate change. So we know that due to climate change, sea levels rise, and when sea levels rise, it will in the end result in coastal retreat, because the water level in the end is higher, so it will approach the beach in a higher way. But more importantly, And we see that part of the effects of climate change is that storms will be more intense, or monsoon seasons will be stronger, and that leads to more erosion than accretion in a dynamic situation. And as a result of that, beaches erode. So even without any human intervention, we would see, let's say, the beach retreating as a result of climate change. And one of the conclusions to be made here is that we know climate change is happening. So if we don't do anything to increase the coastal resilience, erosion for sure will happen. So measures are for sure required, otherwise the beach will erode anyway. So obviously, as I said, there's solutions to work against coastal protection. So I will touch upon a little bit of what kind of solutions can we think about. Obviously, this is not going into high detail, but I will touch upon the main, the key understandings. So what are the benefits actually of protecting the coastline? Obviously, you not only mitigate the negative impact of coastal erosion, but you also protect the development itself, and you also protect the beach. So without coastal protection, if the beach is gone, there's also a loss for the natural environment, but also for the society as a whole. So people enjoying on the beach is not possible anymore. Coastal erosion also reduces the risk of loss of property. So what we see is that the beach is actually quite a good natural protection against, for instance, storms or typhoons. And without a beach, the damage to property during storms is often much higher. And coming back to what I said earlier, a nice beach also enhances the value of the investment. And so a property will be much more valued if there's a nice beach line in front of it. And lastly, if there's proper coastal protection, it's ready and resilient for the future to be ready for the effects of climate change. So what kind of solutions do we have?
Các giải pháp mà chúng ta có thể có được, có rất nhiều các giải pháp khác nhau mà chúng ta có thể tính tới. Đầu tiên là quay trở lại với những phần mà tôi nói phần trước, đó là bãi biển cần có khoảng không để thở, nên là cái việc mà quy hoạch và quản lý rất quan trọng. Không được phép xây dựng các cái công trình quá gần bờ biển và đảm bảo rằng là bờ biển có cái khoảng không đủ để mà phát triển một cách tự nhiên. Thứ hai nữa là chúng ta có các cái giải pháp mềm về mặt công trình, gọi là nuôi dưỡng bờ biển, mà chúng ta phải có thể bơm thêm cát trong bờ biển để giúp cho chúng ta có thể làm cho bãi biển nó ổn định hơn. Và
lastly, we have hard solutions, engineering hard solutions. So you see a few examples here. Right? These are, let's say, rock structures which limit the effect of waves on the beach. And as a result of that, they keep the sand on the beach in a stable way. Most of the time, the best solution is a combination of the above. Often we see that a combination of, for instance, engineering hard solutions and beach nourishment and giving space to breathe is often the optimal solution for a particular coastline. So when we think about these protection solutions, how are we developing these? What steps would we normally make to come up with solutions for these properties? There's a few steps we often made in when we develop the solutions, and I will try to highlight step by step how these steps are being made and what kind of activities are important. So the first step often is an inception phase where we try to understand the dynamics. As I said earlier, it's very important to understand the dynamics of the coastline to come up with proper solutions. So what we try to do in the first step is often identify the key issues. So why is erosion happening? Is it a result of storms? Is it a result of human structures in the neighborhood? What is the reason? Secondly, data collection supports that. So there's a lot of data available which can support building up that understanding. Thirdly, we always, when we want to prepare coastal protection solutions, we also need to identify what are the requirements. What type of coastal protection do we need? Are there any requirements from a master plan, regional master plan or national master plan? What are specific requirements from the property development? For instance, if it's a resort, are there swimming condition improvements required? And lastly, obviously, we would like to minimize the negative coastal impact as much as possible. So identifying these kind of requirements in a first step is important. A second step would be that we select a wide range of concept alternatives. And so these are all alternatives to protect the coastline against coastal erosion. And you see some examples here, but it can be many. Also, as I said, planning or beach nourishment, etc. But preparing a lot of alternatives is often good to do an evaluation, which layout concept alternative is the best. If we review these kind of concepts, we take into account, for instance, what are owner preferences. So there's if there's a development on the coastline, what does the owner want? Secondly, very important, as I said earlier, what are the specific coastal impacts of each of these alternatives? How can they be quantified? In this step, often also stakeholder involvement is important. So the previous presentation also said it's often common interest to come up with sustainable solutions. So here in this layout assessment, we look into, we often talk to various parties to see what the best solution can be. And lastly, we'll obviously also look at costs. It's often an investment to make coastal protection. However, it also has a lot of benefits, especially over the lifetime of a structure and a development. So that's why life cycle costs are important. This assessment often then results in a preferred layout. A more detailed step, when we are looking into a more detailed step about how we develop these kind of engineering solutions, we would typically do surveys, surveys of the seabed, metocean surveys of waves, currents, and geotechnical information. This is all needed to gain information in the understanding of the coastline. One of the most important tools which we are using is numerical models. Numerical models are able to calculate the longshore transport, what I presented earlier. And these numerical models can also then quantify and estimate what the impact will be of these various coastal protection solutions on the coastline. And by testing various of these alternatives, we can select, let's say, an optimum solution, which protects obviously the beach at the project, at the local location, but we can also limit the impact of the development of the adjacent coastline. When we have a good understanding of the required solution, and we go to more detail into schematic design of the structures that can be groins or breakwaters, etc. Now, lastly, when we have a good understanding and exactly know the dimensions of the structures, we do a detailed design in which we very in high detail design these kind of protection solutions. That can obviously, I show here one example, rock, but it can also be a detailed design of a nourishment or a planning solution. One of the speakers after us will also tell a bit more in detail about physical models. Physical models can be used to test some of these protection solutions, whether they are suitable for the local climate, but also whether cost optimizations can be made. So this can be a tool for in the design. And lastly, obviously, it's construction. So my presentation. So what are the key takeaways? What we would like to convey and would ask the participants to bring home later this afternoon. So firstly, coastal erosion destroys property and reduces the quality of the beaches. As I've shown, it's not only for tourism, but it's for all kind of industries. And because of a vanishing beach, the appreciation would be lower and we lose, let's say, the natural value of the coastline. Erosion occurs as a result of various causes. It's natural dynamics, human interventions, and also climate change. We have to understand these natural processes to develop resilient coastal protection solutions. So we have to have a good understanding why it's occurring, why does coastal erosion occurs at that site. And when we develop design solutions, and we go from step by step in let's say, understanding why, what solution will be best for the site to protect against erosion. And when we come up with these solutions, we need to consider also the adjacent coastline, and collaboration with various parties is required. If we don't do that, we may solve it at one location, but we create problems in other locations. So lastly, so if we want to have a nice beach, it's a common interest for us all. So engineers, but also developers, maybe the government, institutes, universities, so that we work together and then come up with good solutions to protect our coastline of Vietnam. Thank you for your attention. Back to you, Justin.
Thanks, Joost. Very interesting presentation. Good to see the different solutions on offer, and good to see the questions coming through, and we'll get to those at the end of the presentation. Our next speakers join us from the Water Research Laboratory in New South Wales, Australia. Matt Blacker is a chartered professional engineer specializing in the field of coastal processes and hazards, estuary processes, coastal structures, and coastal climate change adaptation. He is joined by James Carley. James is a principal coastal engineer with over 30 years of experience. He has served on the Engineers Australia New South Wales Coastal Ocean and Port Engineering Panel, and is currently chair of the Engineers Australia National Committee on Coastal and Ocean Engineering. Over to Matt and James. And I think you need to stop sharing your screen, please, Joost. Thanks.
Okay, can you hear me and see my screen? Okay, thanks everybody. So I'm going to talk about the history of coastal structure design and physical modelling. Let's just see. Okay, it doesn't seem to want to go full screen, so I'll persist how it is now. So where Matt and myself work, the Water Research Laboratory, is in Sydney, Australia. We've been operating since 1959. Sydney is very famous for its very famous building, the Sydney Opera House. We also have many high quality beaches. We also have fairly unique ocean pools that are right on the edge of the ocean as well. And the Water Research Laboratory is situated close to the ocean in Sydney, and we sit here beneath an old dam. So we have water, and we do coastal engineering and groundwater and civil engineering hydraulics. Just a little bit about me. Justin's already introduced me. So yeah, I've been a coastal engineer for about 30 years. I'm also a surfer who rides the waves in the ocean. I've been doing that for 45 years. Also a lifeguard and lifesaver that rescues people in the ocean as well. So I've done that. I train junior lifesavers as well to become lifeguards into the future. This is me riding a wave when I was a bit younger and more crazy. And I'm also the chair of Engineers Australia's National Coastal Committee. So some of the earliest coastal structures around the world wasn't so much for houses or tourism like we have now. It was because of shipwrecks. So the ships would go around the world for trade and they get smashed onto rocks. So then society started building lighthouses to prevent the shipwreck. So this was the earliest lighthouses built. This was an 1824 book picture, a drawing of a lighthouse in Scotland. And believe it or not, this is about the earliest physical modelling I know of. And this is a reproduction. So this is not a real photo because there was no cameras in 1800. But when they designed this, the Bell Rock Lighthouse in Scotland, they actually set up a system that they filled up with water, and they built the lighthouse in front of the water tank and then ran a jet of water down to see if the lighthouse would collapse. So this was around about 1800, the first physical model I know of in the world. And they always, with the physical modeling, you always try and test it to destruction. So if it stands up, you always put a bigger event in and a bigger one and a bigger one to work out how much it can actually handle before it actually collapses. Now that was the Bell Rock Lighthouse in Scotland. That was the 1800 physical model. That lighthouse was built in 1807, and here it is present day, still there. So it's now the oldest lighthouse in the world. That's sitting in the waves. So it's in the tidal zone. It's hit by waves every single day, and its design was originally optimized using a physical model. So that was one of the oldest examples I can find. Moving a bit more into the modern era. So some of the recent coastal engineering references. So the first major reference in coastal engineering design comes from 1938 by a Spanish engineer, Iribarren, his name was, and he still has legacy in coastal engineering. So he published a paper about how to work out how big rocks need to be to withstand a certain size wave. And that got translated into English, which is my language, in 1949. In the 1950s, the US Army Corps of Engineers came along and started doing their own work. So what's called the Hudson equation, which is still used to this day from some coastal engineers for rock breakwaters, that was done in 1953. So then from the 1950s onwards, the US Army Corps of Engineers became one of the dominant thought leaders in coastal engineering. So they started producing major publications starting in 1957. And my organisation, Water Research Laboratory, where Matt and I work, we opened in 1959 to provide advice in this realm. 1973, what was called the Shore Protection Manual was produced, and that is still one of the iconic textbooks for coastal engineering to this day, and it got revised quite often up until 1984. There was a lot of coastal engineering work in the Netherlands, and I have Dutch colleagues here today. I won't speak on their behalf, but the very famous Vandermeer equation, it came out in 1988 from the Netherlands, and that's very commonly used now for rock breakwaters and rock seawalls. 1991, England put out what's called the Syria Rock Manual, and there's been a revision in that. And then during the 2000s, the US Army Corps of Engineers revised their shore protection manual into a coastal engineering manual. Along the way as well, the Swiss International Standards Organization put out an international standard about the actions of waves and currents on coastal structures. So that's a brief summary of available documents, major documents for coastal engineering design. And this is just really the front cover of some of those documents. So this is the 1977 Coastal Engineering Manual, and it is still used by a lot of coastal engineers for some design purposes. And the one on the right is the 1984 Shore Protection Manual. It's still very widely used, and there's parts of that are still remain state of the art, even though it's supposed to have been replaced by the Coastal Engineering Manual, which is a 2000s type document. And there's also a lot of really interesting information in the Rock Manual, which comes from England, the UK. So a little bit of a history of coastal modelling, physical modelling in Australia. This is the earliest photo I can find in Australia of a physical model. This is a harbour development in 1951 in Australia. And this is a more recent picture of what a physical model might look like in action. And it's doing two different things. It's looking at the stability of the rocks sitting here to see how stable those rocks are. And it's also looking at this wall on the top of it to see how effectively the wall can stop the waves going over the top of it. So it's doing two separate things, that physical model. So all the textbooks and the design codes that I mentioned earlier, they all provide calculations for how to design coastal protection works, but they all recommend that the publications are used for initial design. And then if it's an important project, you need to physically model it, because that's the only way to get high certainty in the design. So by physically modeling it, it does the following things. It reduces the risk of failure. That's probably the most important thing, but also can reduce the risk of over-design. So it stops the structure being more expensive than it needs to be. And it provides a faithful 3D picture or model of the project, which is really nice to look at. It allows very large storms to be visualized. So you can dial in any event you want and see what it looks like in the model. So the physical model almost always pays for itself through reduced risk on the project. So some of the pioneering work done by the Water Research Laboratory over the last few decades were CBs. These were done in the 1970s. They look like a beehive, concrete hexagon. So these 1970s, they were developed at Water Research Lab. Here's a model test of a CB wall happening. These are geobags. So these are large sandbags full of sand. So this is one close to us. They're often used for short-term protection. And we also did a large amount of physical modelling on these to test them to destruction, and came up with design curves for the geobags to work out how big a wave the geobag can withstand. Something a bit more recent. So this is the major coastal road in New Zealand, and waves come over the top and damage the cars and the people and the bicycles here. So the waves come over the top of the wall here, through the channel here, and you can see the outcome on the top left. So we did a physical model of that and ran the waves over onto it, and we can find ways to reduce the overtopping, either through putting extra structures at the base or putting another wall, a wave return wall at the top of it here to stop the waves coming over to protect it. For temporary protection in Australia, the most common product used in recent years is what's called a Kiowa bag, which comes from Japan. And these look like, it's a netted bag full of rocks and it can be handled by a crane. They're quite quick to fill. So they've been used for emergency protection in Australia in recent years. But you can see it here in front of these houses to stop these houses collapsing in. So we're just at the moment doing some design curves for those where we build a revetment out of Kiowa bags and we run waves and we work out how big a wave they can withstand before they fail so that we can develop some design curves so that they can be designed better. So I'll now hand over to Matt Blacker. Thank you for your attention and I'll be here to answer any questions at the end. Thank you.
Okay, hopefully you can see my screen there. Is that all right, Justin? Okay, very good. Okay, thank you everybody and good afternoon, it's good evening for me. I'm going to pick up where James left off and provide a bit more of a contemporary summary on the use of physical models as a design tool within modern coastal engineering projects. And we've heard previous speakers talk about some of the dynamics of the coastal zone and the challenges of building infrastructure in the coastal zone or having infrastructure closely positioned to the coast. The coastal zone is a very unforgiving place to have infrastructure, and it's also a very unforgiving place to design infrastructure. And if we get it wrong, we can often make the problems of erosion or sea levels or wave hazards worse than what they were to start with. So models are a tool, as you pointed out, that really allow us to be able to design with a little bit more understanding and certainty of what the coastal processes are and the localized coastal processes are, and to be able to predict a little bit more about how the coastline might respond to a certain change, like the construction of a groin or something along those lines, so that we can resolve issues and not make issues worse for our neighbours or for the site. In my presentation, I'm going to really step through 5 things. Firstly, I'm going to talk about the different types of models that are used by coastal engineers. And I'm then going to talk about some of the selection processes and why we might choose a numerical model for some problems or a physical model for other problems, and look at about how we might arrange a physical model to solve a particular type of problem. I'm going to run through some nice examples of contemporary physical modeling projects that we've looked at in the past few years and give you an idea of the different types of physical models and how they're used for coastal problems. And then I'm going to provide a quick summary at the end on some of the advantages of physical modeling in particular as a tool, but modeling more broadly. So we've heard a fair bit of discussion so far about modeling, but if we just take a little bit of a step back and think about what a model is more broadly, a model is just a representation of some process. And in the coastal zone, this process could be anything. It could be the waves breaking on the beach, which is what I've got some animations showing here for. But it could equally be the longshore drift, a simulation of that longshore drift process, for example, that was talked about before, or it might be waves breaking on a coastal structure. And when we think about models in the coastal engineering sense, there's really 3 types of models we look at. There's empirical models, which simulate that process using perhaps previous measurements from field data or laboratory studies. More complicated than that, there's numerical models, which are computer models where you solve some mathematical equations to simulate a process, and that's what's shown in the middle picture there. And then we have physical models, and a physical model really is nothing more than taking all the processes or the physics that's going on a site and scaling that down and making a small version of it. And we make sure all those physics or the key important processes are reproduced in the right proportion and the right forces. So in that bottom animation there is just showing a plunging wave breaking on a beach. And so we've got ways of scaling all these things down in a physical model to get those processes to reproduce properly. So they're kind of the 3 different types of models in a coastal engineering sense. In the coastal environment, it's been pointed out already, there's a few reasons why we might do some modeling. Really, what we want to do though, is we want to be able to predict the response of a coastline or of a structure to the forces and the processes that are going on. So we might want to be able to understand the response of a beach if we put a groin in or a seawall in or a breakwater in. We also want to be able to predict the response of a revetment or a structure to perhaps a typhoon or a large wave event, so that we don't get that wrong and we don't end up with failed structures all along our coastline. So the modelling really helps us to understand and to be able to predict these kind of things ahead of time before we go and build these structures. Models are also used to compare different options. They're used to demonstrate and engage with stakeholders to be able to show what the outcomes might be of a project. And they're used for risk assessment and development of management strategies. If we take a look at modelling in coastal engineering projects, when we're thinking about what kind of model we want to use, we can really think about it in a number of ways. What we have to have a look at is the size of the processes that we're looking to simulate. And I've got this on the vertical scale of this plot here, so the spatial scale from meters through to kilometers. And we also have to think of the time scale that the processes are happening over. So we might have, really big scale processes that happen over days or months. And they might be things like ocean currents or tides, might be over hours or days. And they happen over a big area. Then we, at the bottom end of the scale, we have things like wave overtopping. And that happens over seconds or minutes and a much more localized scale. And so when we're thinking of a modeling approach, it's often good to think about the spatial scale and the time scale that the processes are happening over. And from that, really what we see is that physical models are most suited to problems that happen over a shorter time scale and a smaller area. And so that's shown by the top right here, where we've got looking at wave overtopping hazards in a physical model. Compared with something like ocean currents that happen over a big scale, we can't capture that big physical scale in a physical model. That might be things like ocean currents. And then there's an area in between where you've got things like scour around structures and beach erosion. But generally, physical models are smaller, shorter duration processes are what they're suited for. We also want to have a think of the complexity of the processes and what's going on. And the coastal zone is often a very complex place. On the far right here, we've got very complex processes like waves causing damage to a structure. And we've got wave overtopping or scour. And then at the other end of the scale, we've got more simple processes like ocean tides moving around the world. And so physical models are really suited to problems where there's a high degree of complexity versus numerical models that are probably best suited where there's a somewhat lower degree of complexity or in the middle, lower or moderate. And on the right-hand side there, I've shown two different types of model, both from Darwin in the Northern Territory of Australia. The top photo shows a big spatial scale numerical model covering a big area and looking at a long duration processes. The bottom picture shows a wave slamming into a seawall with an overhanging walkway and the overtopping of that seawall. And we're actually measuring the loads that the waves apply on that wall for design purposes. So there's a very high degree of complexity in that bottom picture. And it's very difficult to capture that with a numerical model, for example, and those design loads accurately. So we would choose to physical model that one instead of numerical model. In terms of approaches for physical modeling, if we take a sort of a big structure like this reclamation here, this is a Gorgon Western Australia project. It's an LNG project that was developed a few years ago. In this particular case, we could choose to do what's called a 2D model, which is a slice through the structure just in two-dimensional. And we've got the pictures of that model on the right-hand side here, where we're looking at the armor stability and the profile of the coastal protection there. That's a very simple 2D physical model. Where things might start to have some three-dimensional processes, we could increase the complexity a little bit of the model. And in this case, we've got models of the head of the reclamation and the head of the breakwater structure here in what we would call a quasi three-dimensional model, where we've got perhaps 2D waves, but breaking on a three-dimensional simulation of the structure. And then we have a full 3D model of the same structure. And this is where we're looking at, again, a higher degree of complexity. We're looking at waves diffracting around the breakwater head and what are the size of the waves getting into that harbour and various different processes like that. So there's different ways that we can break a problem up and model it. And depending on the size of the project, you might do simple 2D modelling through to more complicated 3D modelling. I'll quickly show some examples of some nice physical modelling projects we've looked at in recent years. This one is from Abu Dhabi. And in this particular case, we were modelling these large sandfield geotextile tube breakwaters. And in particular, it was to look at the arrangement of these breakwaters to provide protection to this nourished beach, this artificial beach for this hotel. The physical model was used to look at waves overtopping the breakwaters and how the arrangement of the breakwaters impacted the currents behind the structures themselves, and to make sure those currents weren't too strong for swimming or for that sand to be stable behind those structures. The next example is the project called the Palm Beach Shoreline Project on the Gold Coast in Australia. This was an artificial reef that was being designed to build up sand on this beach behind it and to provide protection to these properties on the beach, right at the back of the beach. In this case, there were actually 3 different physical models completed for this project. The first model was a big 3D wave model, and it was really focused on the shape of the reef and the size of the rock armor that was needed to be stable. The third model was, again, a larger scale 3D basin model, and it was really focused a little bit on the rock armor stability, but more on the hydrodynamics and the currents that the structure generated. So you can see here we're using some dye to look at the wave-driven currents in the lee of that artificial reef. And we also have some lightweight sediment on the beach, looking at how that sediment was moving in response to that structure for different wave climates. The physical model, it really does allow a high degree of complexity to be reproduced, and you can see the shape of the waves and how the reef is deforming those waves and the subsequent impacts on the beach and the currents and that kind of thing. That's just the structure under construction in the top right there, and the finished structure dissipating waves in the bottom right, and an aerial photo of it. This particular project was a detached breakwater, and the physical model was used to investigate the structural design of the breakwater. So the right-hand side here shows some laser scans of the model where we were looking at displacement of armor stones off the structure and trying to work out how big the rock needed to be and how high the crest should be. We were also looking at the response of the beach to this structure to make sure it wouldn't cause additional erosion, and it would in fact generate some accretion of the shoreline. This example here is for a jetty structure, and we were using the physical model to measure wave impact loading and get the structural design forces on that particular structure to feed back to the engineers designing it. And lastly, this is an example of just a 2D revetment model where we were using this model to investigate, again, the size of the rock armor to provide a stable solution, and also the height of the crest of the revetment to resist typhoon waves. This is in the Philippines. And you can actually see under some of the bigger waves here that the armor stones are actually dynamic, so that the waves are actually able to move them. So the physical model, again, allows us to visualize the problem and be able to predict very accurately how big those stones should be. So in summary, physical models and numerical models, they're both great design tools for coastal problems to allow us to predict ahead of time how a piece of coastline might respond to perhaps an intervention or to a future sea level state or wave problem, or a big design storm or something like that. Physical models have particular advantages where there's a high degree of complexity. So if we're trying to look at something like waves impacting on a seawall, and we want to be able to build that seawall strong enough that it doesn't fail and make problems worse, or where perhaps you might have a structure that could cause additional erosion to your neighbours, and where it's very complicated, where there's a lot of things going on, which is often the case in coastal problems, that's where physical models are the best solution we have to simulate that. They allow us to visualize real situations at small scale and to be able to test changes to a design quite quickly and look at the implications of those changes. As James said, they really allow us to have the ability to save on construction costs and optimize design costs, which is another big advantage of them. Some disadvantages, they're limited in the spatial scale that we can reproduce, and they're limited in the duration of the events we can reproduce. So contemporary physical models, though, they're not usually used, perhaps in the older days, like James showed, They were used as a sole design tool. In these days, they're nearly always used in combination with numerical models, where you might have a computer model predicting wave processes for a bigger area, and then that forms the boundary condition for a physical model, for example. So that's almost always a partnership is the best approach these days. And we like to see physical models used at different stages of a project. Really could be for rapid concept or proof of concept testing, all the way through to design verification at the end. They're a useful tool for different purposes at different points in a project. And as I showed, it's often cost effective to break a project up into several smaller physical models instead of one big one. So that's kind of physical modeling in a nutshell in 10 minutes. Thank you.
Brilliant. Thanks, James. Matt, a really interesting presentation. Fascinating to see that 200 years, more than 200 years ago, physical models are already being used, see how they've developed and the advantages they can bring to a project. Really clear and interesting and fantastic. Thanks very much. We have about 40 minutes left in our webinar. So we have one presentation left, and then we'll finish off with some questions. Our final speaker today is Tan Hai Ha, and he joins us from Kang Duc. Tan Hai graduated from the University of Transport and Communications with an MBA degree in project management. He has experience in major infrastructure projects such as the Immersed Tunnel project in Saigon, the Metro Railway, also here in Saigon, and the Tra Vinh Wind Farm. For those that are currently listening to the interpretation, you may need to switch over. Tan Hai is going to be speaking in Vietnamese. So at the bottom of your screen on the right-hand side, you'll see an interpretation option. Click on the option you're looking for and enjoy this presentation.
Yes, thank you, Mr. Justin. Good afternoon, everybody. It's a very big honor for Kang Duc and me to be here, sharing some ideas about subject sustainable approach to overcoming cultural erosion in Vietnam. First of all, I congratulate Royal Harmony DSV for the 140th anniversary, and special thanks to the organizers, Royal Harmony DSV, the World Bank, the Water Research Laboratory. I would like to introduce myself. My name is Tan Hai. I joined Kang Duc IC in 2020 and have held the position of tender manager for the in marine construction, especially near shore, there are many challenges and difficulties in execution. What are the reasonable solutions to cope such hurdles? Kang Duc IC contractor has successfully completed projects throughout Vietnam and Cambodia coastline, showcasing a series of case studies on how to overcome. The agenda for the topic today comprises in 3 sections: the company introduction, the outstanding related projects, difficulty, challenge, and solution. Now let's start with the first section of introduction. Kang Duc with the mission achieving the customer trust and satisfaction in every project, and the vision become a leading marine construction brand in Vietnam. The driving force for Kang Duc to actualize the target is a solid team gathered by the profile and dynamic leader together with specialized equipment. There are some major milestones. Kang Duc established in 2009. 2013, we transformed into Kang Duc Joint Stock Company. 2018, we awarded the first nearshore renewable energy project as a general contractor for the civil work. In 2021, we are the top 3 EPC contractor in the marine works. And in 2025, we are targeted to be a public corporation. Our main business focus on 4 sectors: renewable energy, marine work, infrastructure, and other services. This selection of outstanding projects relating to the solar protection. The Chavin V11 wind farm consists of 12 wind turbines and over 4 km limb bridge PMU area, and especially the die crossing with 3 steep bronze system. The Anna Marina Nha Trang, the scope of work construction of breakwater, revetment, and the resin for bay. The Climate International Container Port, the construction of topside paving, granite, and revetment, and other features. The Nghi Sơn Refinery Project, construction of 2.8 kilometers stone coffer dam, driving FT, the resin near shore for high operation. The last section is the difficulty, challenge, and solution Camden face in marine construction project. For difficulty and challenge, we can summarize in 5 major categories. And now we go into each category. For the weather condition, the wave, wind, rain, tide, monsoon season, coastal erosion, inaccurate local weather forecast, evacuation plan, and the lack of construction equipment. Of the weather condition on shore, the workable condition of after way. This is the video of severe weather condition on install, workable condition for construction after way 0.6 to 1 meter, square way less than 0.3 to 0.4 meter, wind gust under 10 meter per second or line rain. Nearshore projects, especially intertidal zone, only affected by differential water level in a day, with usual tidal rain between 2 and 3 meters, sometimes 4 to 5. It's made difficult for the equipment arrangement. This is tidal rain table for hour by blue color. Figure is the low tide, the orange is high tide. The left picture construction of deep ground die when low tide. The construction of bridge is suspended by stranded seabed, and the right one is the reverse with construction of limb bridge in high tide and the stoppage of die work. They are assembled for flexible planning execution. Coastal erosion now is one of the few countries heavily suffer from sea level rise caused by the climate change. Consequently, the coastline is increasingly eroded by this reason. This picture shows the new build structure limb bridge affect heavily the coastal revetment regarding to stability and weight resistance. The picture showing simulation of current speed. The left one is without any structure, and the right one is with the bridge structure. In detail, the seaway crack to the foundation structure resulting turbulent flow, washing away mud and sand under the revetment and the structure that's causing the erosion. Here is the diagram analyzed by the My 21 low model program simulated the wave flow based on the design data of Linda Hurricane. The strongest storm ever hit the southern region for nearly 25 years ago in 1997. The left picture shows without any protection. The right picture shows with the protection solution. Kang Đức had acknowledged this potential risk, so we designed and built the 3D ground die to trap the sediment, thereby reducing reflective wave by pressing to the die. And this is the sediment accumulated in base of 3 die. Inaccurate local weather forecast. This figure of weather forecast in a week. This picture shows the weather forecast by the licensed version, but it is not correct at the working region because there are not enough the hydrometeorological station to monitor the weather figure throughout the country, causing trouble for the contractors to set up the realistic schedule for the project. Here is the map describing the evacuation route for equipment in emergency case. This is the same refugee location on river for equipment after evacuation. Refugee area for equipment and workforce shall be planned in advance and practiced in trial before extreme weather happens. Choosing the distance from site point to refugee point or master point is very important for safety solution and should be as near as possible while it can harmonize with working schedule and safety issue, and with the motto, safety is the first priority. Other issue and solution. Compared with onshore construction, the legal regulation for offshore construction work is stricter than onshore, like mandatory marine safety plan, marine safety surveyor, vessel register, SFB class. Most of the site had no approachable asset. They various permit approval from government like border police for entrance of equipment and laborer, agreement for location of construction on sea, the EIA assessment, the environmental impact assessment on how to protect the environment, aquatic, resort, coral. For environment research, Kang Đức had acknowledged the issue and equipped with acoustic wave and current profiler AWAC to measure current and wave for the purpose of study tidal currents, coastal erosion, design data for planning of new coastal structure. The material for offshore work frequently react with highly radiated sunshine, below wind, static corrosion of seawater. Thereby, material criteria shall be higher than onshore structure. And mandate a covering system to protect structure like painting, galvanizing layer for steel, epoxy, or silica impregnation coating for concrete structure, heavier thickness for steel and concrete cover. The equipment suited with offshore work are very scarce, old, easily broken, mobilization taking for a long time. The workforce to be familiar with offshore work is very few, hardly recruited with good physical health, can resist again travel ship on sea or work anytime when weather is workable. As such reason, The contractor must have the contingency planning of backup equipment and manpower for nearshore work, so as to catch up the schedule while not know how the upcoming weather is and the deadline is very tight, so that the cost shall be increased approximately by 30% in budget. Finally, Kang Đức has creatively devised the suitable planning, working methods, specialized equipment to deal with all the challenges and difficulties. This is the end of my topic today. If you have any query relating to the method, you can ask us at the QA section, or please reach out to us on the website. Thank you for watching.
Hi, very interesting presentation again. I'd like to thank all our panelists for their presentations, all very interesting, very informative, covering a wide range of topics and all finishing exactly on time. So good to see we have time for Q&A. And I've seen quite a few questions coming through already. Some of them have already been answered or responded to in the chat. I'm going to pick a few of them anyway, because I think it's good to discuss them a little bit more here with the panelists. And I hope you're going to stay with us for this section as well. So we started off with the presentation by Zung and Matthijs, and looking at the work that the World Bank has been doing, and how the World Bank has been funding projects in Vietnam. And one of the questions that came up was about the role of PPP. And let me just see what the question was. It says, it's very clear that erosion hazards are real and increasing in the coast of Vietnam. How do World Bank advise Vietnam with possible integrated solutions? How can PPP scheme be applicable here? Would you like to answer, Matthijs and Zung?
Yeah, let me take the first kick and Matthijs come in afterward. Thank you very much for the question. I think this is a very interesting question. Again, that what we presented in the slide, that the erosion is actually part of the multiple problem in the coastal area, which actually caused by the natural hazard or natural dynamic of the coastal area, but it's also due to the human intervention. In many places, actually the wrong intervention in the coast actually cause more problem for the communities and the business activity there. So at the first step, I think for the long-term and sustainable solution, it has to be also to be better understanding. Again, it's not to the individual, person or individual in the government system or any partner, but also to view the better understanding of the risks through the planning and the decision-making process in both the government and communities and also private sector as well. Because you see a lot of, the case of Phan Thiet, for instance, you see the individual intervention of the resort owner actually create, in our views, create more problem for the erosion prevention. But also create a problem for the tourist business development, as the coast look more ugly and more dangerous to the tourists. So this is very important. The second of all actually is to maximize the efforts from the different player in this field, particularly like the PPP is one of the opportunities for both the government, the public, and also private sector to work together and to maximize the resources, but also to maximize the benefit from the erosion prevention. Again, the case of Phan Thiet, for instance, it actually requires some sort of larger scale intervention to prevent the erosion that benefit to the resort owner, but also the community living along the coast. That Phan Thiet's case provide exactly the very good opportunity for those triangle, let's say, the triangle coordination and collaboration, particularly between the public sectors, private, and the community to work together for this. So I will stop here over, over to Marta, if you want to add something more.
Maybe one thing to add, the question is also about, let's say, how does the World Bank support Vietnam? So the case of Vietnam was an example of a project that was done in very close collaboration with the Vietnamese government and also the stakeholders in the region. So there was a very intense stakeholder process to develop, let's say, together with public and also private stakeholders, this solution. So in that way, we try to, as the World Bank, we try to support, of course, the let's say, some sort of and introduce a new line of thinking about, let's say, how can we further support the development of these more integrated and large-scale solutions rather than, let's say, what Zoom already was saying, these spot solutions for individual assets, and also help to foster the discussion between the private and public sector about how can perhaps a scheme look like and how can it be financed, let's say, between both by both, let's say, public resources, but also by private resources, because both have an interest in this coastal zone, and both also are already investing in the coastal zone, but through a more integrated solution, let's say, also those resources could possibly be invested in a more efficient way. With that, back to you, Justin.
Thanks very much. Joost, I've got a question. It's a two-part question for you. The first part is, does coastal erosion depend on the region, or is it the same along the whole coast of Vietnam? And then the second question, which I've linked to this, is, and are there examples of works that are considered successful, and can we copy and paste as we go along where we see?
That is an interesting questions, of course. So I think answering the first question, so the answer is no. So the question was, are these solutions or the concepts and erosion and the solutions the same along the coastline of Vietnam? So the answer is no. Obviously, when we look at the coastline, especially in the middle of Vietnam, we see a lot of sandy coastlines or rocky coastlines, and the Mekong Delta and further north, the Red River Delta, often they are more natural. For instance, in the south, you have a lot of mangroves. So the causes of erosion are different. So there's different processes. Different processes are in play, let's say, which makes the coastline erode. But I think the concepts are the same. So the concepts are presented, the natural dynamics, human interventions or climate change, those concepts are the same. But the way we should look at the different systems is different. So I think if we, let's say, if we would study coastal erosion and come up with, let's say, solutions in terms of planning or structural solutions, you would also then choose differently because the processes are differently, and therefore the solutions are also differently. I hope that answers the question.
Can I maybe add one thing, Joost, just into this? And it's also a response to what was just said in the chat. I think the coastal erosion and the coastal processes that we've been mainly discussing here, I think today, are mainly, let's say, the issues that we see in the, let's say, the so-called closed coast, where there is a lot of effect of the outflowing rivers. But there are, of course, also sections along the Vietnamese coast where you see that the rivers flow out into the sea and also provide sediments towards the coast. So in those sections, and that's also what we did with in this hotspot analysis as Resilient Shores program. And we also looked specifically for those areas also to the effect of the river and also include that part into the analysis, because I think what is being said in the chat, I think, is very true. I think for those particular areas, I think it's also very important to take the river and the outflow of the river and the sediments provided by the river to the coast also carefully into account, because those could also affect. If you have, for instance, blockage of sediment in the river by a reservoir, it can also lead to, let's say, a shortage of sediment at the coast, and also, let's say, a regression of the coastline. And it is a different mechanism, but it's it's in certain places definitely also ongoing.
Exactly. And may I add here, that's very quick. I saw some of the questions related about the coastal erosion in the Mekong Delta. So our colleagues, Mark Titus mentioned about, that's the blocking of the sedimentation transport from the river to the coast is one of the key. I think is one of the key counter erosion in the coastal in the Mekong Delta as well, because in the region, let's look back in the past few years, you see a lot of sand mining were booming in the Mekong deltas, and that actually is made actually also to capture a lot of sand that was supposed to be actually run out to the river mouth and the coastal area again supply for the coastal for the coastal line. But at the same time, of course, you have already aware in upstream there were a lot of a reservoir actually built, particularly especially in further upstream countries like China. You see also block a lot of the sand moving down from upstream to down. So again, the erosion is actually about the balance of the sands between the upstream to the downstream anyway. Thank you.
Excellent. Thanks very much. Next, over to James and Matt. It's getting late in Sydney. I hope you're still feeling sharp. I see there's already been quite some discussion in the chat on this question, but I think it's good to open it up to you to just elaborate a bit more. And the question comes down to, what is the relationship between a physical model and a numerical model? And is it practical or believable to just use a physical model?
I unmuted first, so I'll speak first if you like, but I'll let Matt. Matt had some slides in his presentation that did cover this. So ultimately it comes down to engineering experience and engineering judgment to choose the best tool to solve any particular problem. And any complex real world coastal problem, it will be a range of tools to apply. So it will be a numerical model for some of the processes, for example, the waves and the longshore sand transport. It would be using desktop methods, so pulling out reference books like Shore Protection Manual or Coastal Engineering Manual to come up with a preliminary design if you're going to design structures. And then to get the structure design right, you'd most likely use a physical model to size the structure, look at the forces, look at the wave overtopping. So it's very unlikely nowadays you would use a physical model for everything, but before the advent of computers, that was how things were often done. So there was large physical models as big as a football field of pieces of coast were done in the 1940s and 1950s. But as computers started taking off in the 1960s, they started being able to solve a lot of the problems, a lot of the more simple problems, and then that becomes the interface with the physical model. So yeah, you use a combination of all three, and a lot of the skill and the judgment is to know what might be the best tool to solve each part of the problem.
Brilliant. Matt, do you want to add anything to that?
Look, I agree with what James is saying. That's exactly right. And the most successful projects I've seen, in particular for complex situations, have always drawn on different tools to provide a solution, and really the experience and judgment of the engineers to pick the best parts from the different tools and say, this is our solution. That's where the tricky bit is. Any of the models, physical or numerical, are only as good as the information that's driving them, and they all have boundary conditions and that kind of thing. So often these days, as I pointed out, a coastline is not a confined compartment. A coastline has things coming into it, whether that's waves or whether that's sediment or what have you. So a physical model could never really capture all of those things coming into it. At some point, you have to have waves entering, or you have to have water level changing or sand coming and going. And so a physical model can never capture all of that scale. So you have to have some way of driving that physical model, and that's where a numerical model is particularly useful. At the heart of it, though, it depends on what you're looking at. If you purely wanted to look at a structure response to a wave, say a revetment response to a wave, and you had a very good understanding of what that wave was that was impacting the structure, or a force on a structure, for example. What is the force on this structure from a 6 meter high wave? then a physical model would be able to tell you that directly. But it's how you come up with that wave that you're driving it with that in, you know, what your design is. Do you need to look more widely to other tools?
Nice and clear. Thanks, Matt. Tan Hai, I've got a question for you. You mentioned that the weather predictions are often not reliable. What does this generally mean for Kangduk as the contractor when they're working in the marine environment? What consequences does it have? And how do you deal with that?
Kangduk là cái gì? Và chúng ta đã giải quyết vấn đề này như thế nào?
For your question.
Cảm ơn trong câu hỏi của anh. Anh biết rằng là cái dự báo thời tiết thường là theo từng khu vực một thôi, chứ không chính xác cho khu vực làm việc, cho dự báo cho một khu vực lớn. Và cho cái khu vực làm việc của chúng tôi thì chúng tôi phải giám sát mà các điều kiện thời tiết theo giờ, và vì nên chúng tôi phải giám sát hàng giờ và hàng ngày. Và với các cái quan sát như vậy và tùy vào điều kiện thời tiết thì chúng tôi sẽ quyết định liệu chúng tôi sẽ làm việc hay là chúng tôi sẽ phải rút các thiết bị của mình vào. Và nhất là trong cái mùa gió mùa thì mọi người đều biết rất là khó để triển khai. Thì bây giờ chúng tôi vẫn có thể làm việc được, ví dụ như ở Cà Mau chẳng hạn, dựa vào những cái kinh nghiệm của chúng tôi, chủ yếu là như vậy. Và với những cái kế hoạch và dựa vào cái quy trình lập kế hoạch của chúng tôi để chúng tôi vượt qua những khó khăn này. Và cái thời gian làm việc thì nó cũng sẽ được kéo dài do các cái điều kiện này. Và chúng tôi cũng có kế hoạch dự phòng để mà cho các cái thiết bị của mình và lên một cái kế hoạch từ sớm. Vậy là vì thế nên cái chi phí xây dựng cho các công trình này trên biển ấy thì thường là sẽ tăng lên khoảng độ 30%. Trong một số trường hợp ấy thì tới 50%. Xin cảm ơn. Chúng ta vẫn còn có thời gian cho 2 câu hỏi nữa trước khi chúng ta kết thúc. Và tôi sẽ xin có câu hỏi mở cho tất cả mọi người. Mọi người cùng trả lời. Cái câu hỏi đầu tiên là câu hỏi về có cái hành động nào từ phía chính phủ Việt Nam đối với vấn đề về xói lở bờ biển hay không? Thì đâu là những cái giải pháp đang được thực hiện bởi chính phủ Việt Nam trong những năm vừa qua để giải quyết cái vấn đề xói lở bờ biển này? Đây là một câu hỏi rất là khó. Cái câu trả lời là có và không. Có nghĩa rằng là chính phủ đã thấy rằng là cũng đã tiến hành một số các hành động để mà ngăn ngừa xói lở, nhưng mà các hành động này thì thường là mang tính chất là đột xuất và không lâu dài. Và từ những kinh nghiệm làm việc của chúng tôi ở Việt Nam, đặc biệt với chính phủ, thì chúng tôi chưa nhìn thấy một cái kế hoạch lâu dài và toàn diện, chương trình toàn diện và lâu dài để mà ngăn ngừa xói lở bờ biển ở Việt Nam. Vẫn nhiều các dự án đầu tư bởi chính phủ và một số các đối tác khác, nhưng mà các dự án này thì thực sự là chỉ là đáp ứng một số các cái vấn đề ở từng khu vực một thôi. Nên là như tôi đã nói trong cái bài trình bày của chúng tôi thì Ngân hàng Thế giới đang làm việc với chính phủ Việt Nam để thực tế là chính phủ đã xây dựng sau cái nghiên cứu phân tích của chúng tôi mà chúng tôi có hỗ trợ để xây dựng ra một cái chương trình lâu dài và tổng hợp để mà ngăn chặn để mà nâng cao hơn nữa cái khả năng chống chịu của bờ biển Việt Nam, bao gồm có chống xói lở cũng như là các cái vấn đề khác liên quan tới ngập lụt. Thì đấy là một trong những cái phần trận thứ hai. trả lời của chúng tôi về cái vấn đề là có là không có một cái giải pháp lâu dài. Không biết ai có muốn bổ sung thêm không? Ok, thì chúng ta sẽ có câu hỏi cuối cùng đi ạ. Đây là câu hỏi là liên quan tới tôi cho muốn mọi người cùng có cái câu trả lời về cái vấn đề chi phí. Thì cái mỗi 1 km bảo vệ bờ biển ấy, cái chi phí để bảo vệ nó sẽ tăng lên bao nhiêu do vấn đề về biến đổi khí hậu? Đây là một câu hỏi rất là khó để mà trả lời. Nhưng mà tôi sẽ xin điều chỉnh cái câu hỏi này một chút. Tức là nếu như mà chúng ta không đầu tư vào các cái giải pháp bảo vệ như này thì nó sẽ mất thiệt hại bao nhiêu? Chúng ta đều biết rằng là trong các bài trình bày chúng ta đều nhìn vào thấy rằng là chúng ta cần phải bảo vệ và cái chi phí các cái tài sản bảo vệ rất là lớn, đúng không ạ? Nên là để mà trả lời một con số chính xác thì rất là khó, nhưng mà chúng ta cũng cần phải tưởng tượng rằng là nếu mà chúng ta không bảo vệ thì chúng ta sẽ thiệt hại rất là lớn, đúng không ạ? Tôi sẽ xin nói một vài điều. Cái này là rất là liên quan tới cái thiết kế của chúng ta, thiết kế các công trình, cái chi phí ấy. Và hầu hết các cái công trình thiết kế công trình thì thường là sẽ có thời gian là 50 năm và vì thế nên chúng ta cũng phải tính tới cái thời gian dài đó nữa, và nhiều khi là chúng ta cũng không tính toán hết được vì xã hội thay đổi rất là nhiều. Một cái ví dụ là đến năm 59 thì lần đầu tiên có vệ tinh lên trên trời, nhưng bây giờ thì chúng ta thấy rằng là có điện thoại di động cầm trong tay và thu tín hiệu từ trên trời, đúng không? Thì chúng ta thiết kế nhiều khi là thiết kế cho 50 năm nhưng mà sau đó thì rất là khó để mà có thể thiết kế được cho cái tầm nhìn 100 năm. Nhưng mà vì thế nên là các giải pháp luôn luôn phải có tính thích ứng để mà chúng ta tới một thời điểm nào đó chúng ta có thể phải đánh giá lại các giải pháp này của mình. Chúng không phải là chỉ đơn giản là có thể có một cái giải pháp nào đó trong 100 năm được. Tôi có thể bổ sung đây một điểm đây, bổ sung đây một chút. Để bổ sung, tất nhiên là rất là khó để mà dự báo về cái tương lai do tác động của biến đổi khí hậu thì sói lở sẽ như thế nào, như các thành viên khác cũng đã nói rồi. Nhưng mà nếu mà chúng ta nhìn vào cái trường hợp ở Việt Nam, nếu mà chúng ta nhìn vào cái sự phát triển rồi các hoạt động kinh doanh dọc bờ biển của Việt Nam thì chúng ta nhìn thấy là từ những nghiên cứu của chúng tôi thì chúng tôi thấy rằng là hầu hết các cái hệ sinh thái, ví dụ như là rừng ngập mặn hay là dạng san hô, đặc biệt là đun cát, là một trong những cái giá trị tự nhiên tốt nhất, hệ thống bảo vệ tự nhiên tốt nhất dọc bờ biển thì đã bị phá hủy bởi rất nhiều khách du lịch, các cái dự án du lịch, các dự án phát triển khu công nghiệp rồi phát triển đô thị đã phá hủy các cái các cái hệ thống hệ sinh thái này. Và chúng ta nếu mà chúng ta tiếp tục như thế này thì cái vấn đề về sói lở sẽ càng ngày càng nghiêm trọng hơn. Cho dù là có biến đổi khí hậu không, như vậy là cái tác động của con người thực sự đã tạo ra những cái vấn đề lớn nhất cho vấn đề bảo vệ bờ biển hay là cái sự ổn định của bờ biển ở Việt Nam. Cảm ơn. Đó là một cái câu trả lời rất là tuyệt vời cho một cái webinar rất là tuyệt vời của chúng tôi. Xin cảm ơn tất cả các diễn giả của chúng tôi, và chúng tôi rất là thích các bài trình bày của các anh, để tất cả đều rất là hay và rất nhiều thông tin và kiến thức. Và xin cảm ơn tất cả mọi người đã tham gia cùng với chúng tôi trong cái hội thảo này, và chúng ta đã tham gia đã dành 2 tiếng để tham gia cùng với chúng tôi ngày hôm nay, và hy vọng mọi người cũng thích cái hội thảo này và cũng rất nhiều các câu hỏi nữa mà có lẽ là chưa được trả lời. Thì chúng tôi xin đề nghị mọi người kết nối với các diễn giả của chúng tôi thông qua LinkedIn. Mọi người có thể hoặc là gửi email thông qua cái đường cái email mà mọi người đã nhận được để tham gia cái hội thảo này, để mọi người có thể đặt thêm câu hỏi. Và xin cảm ơn những người đã tổ chức hội thảo này đội ngũ chị Linh cũng như là đội ngũ truyền thông để thực hiện cái hội thảo này, và cho anh Bình Nguyễn
jump into for a little bit, and it looked like you were extremely busy. Thanks for that. Thank you, everyone. The webinar has been recorded. It will be made available online if you have missed part of it, or if you want to see parts of it again. And we look forward to seeing you again in the future. I'm sure we will have more of these. Thanks then. Goodbye.